Hi, my name is Stephanie, and I'm an experienced American tutor. I will be helping you get through the mathematics past questions of the joint admission and the matriculation board examination. I hope you enjoy my tutoring. Thank you.
Alright, so question 1 says which mathematics question type paper is given to you, and you would just put in D because that's the form that we have with us today. Okay, so question 2 is a change of base question, and it has 2q3 with base 5 is equal to 77 base 8. And so we are asked to solve for q, and so remember that with the normal system that we're used to using, which is a base 10 system, we interpret the 2, 4, 3 as being the sum of 2 times 10 squared plus 4 times 10 to the first power plus 3 times 10 to the 0 power, which would be 200 plus 40 plus 3. But you can do the same thing with different bases. And so using this process, we're going to solve for q. So writing this out like I just did before, we're going to do 2 times 5 squared plus q times 5 to the first power plus 3 times 5 to the 0 power. So remember that when you're working with binary, each position of the number goes up in order going from right to left. So this 3 would be in the 0's position, q would be in the 1, 2 would be 2, and so on and so forth. So that could help you also remember how to position things. So I'll move this down, and then we're going to do the same thing for the other half of the equation, but we're going to do it with 8. So again, going from right to left, this would be 0, this would be 1. So we have 7 times 8 to the first power plus 7 times 8 to the 0 power. Simplifying a bit, we're going to have 2 times 25 plus 5q plus, remember that 5 to the 0 power is 1, so we have just 3 here. 7 times 8 to the first power is going to be 56 plus 7 times 8 to the 0 power is just 7. So we simplify a bit more, and we're going to get 63 on this side, and this will be 50 plus 3 is 53. So 5q plus 53. We subtract 53 from both sides so we can isolate q, and we're going to get 10. So 5q is equal to 10. We divide by 5, and q is equal to 2. And that's the answer. So here we have question 3, and it asks us to simplify, and it has several fractions included, and there's multiplication and division. And so there's really probably about 4 simple steps that you can use to solve this problem. And the first one would be to simplify, or excuse me, to change this from a mixed number into an improper fraction. So remember that you would multiply this whole number times the denominator. So 3 times 3 is 9, and then you add the numerator. So that's 11, and then you put it back over the denominator. So 11 thirds times 5 6 times 2 thirds divided by 11 over 15 times 3 over 4 times 2 over 27. Okay, your next step would be to realize that since all of these fractions are in the denominator, we're basically saying to divide by these fractions. And remember that when you divide by a fraction, you can just multiply by the reciprocal. So I'll show you what I mean. So we're going to keep this part, 11 thirds, 5 6, and 2 thirds. Okay, the denominator, excuse me, the numerator stays the same. And then we're going to multiply by the reciprocal of all of these. Remember, the reciprocal means to just take 1 over the number. So 1 over this would leave us with 15 over 11, then 4 over 3, and 27 over 2. Okay, so now we've gotten this into a more usable form of the question. but there's even more that we can do now. So the next step would be to simplify before we went and multiplied all of this out so that we don't get so confused. And so you want to look for areas in the top and the bottom where you can cancel out. So here is a 2 and here's another 2. They would cancel out to 1. 3 times 3 times 3 is 3 cubed, which is 27. So these will cancel out, all of them, to 1. An 11 and an 11, that can be canceled out. So I'm going to rewrite what we have so far. So this is 1 over 1, so that's just 1. 5/6 is still the same. This is 1 over 1. This is now 15 over 1. This is 4 over 1. And this is 1 over 1. Okay, so we know that when you multiply by 1, nothing happens. So I'm going to take out these. So now we just have 5/6 times 15 times 4. Okay. And what I did there is I just said 15 over 1 is just 15. And 4 over 1 is just 4. So what we could do actually is we could say 6 and 4 have a common multiple, I believe it is, or factor. I always get the two confused, but the point is both of these can be divided by 2. So I can divide this and this by 2. So 6 divided by 2 is 3. 4 divided by 2 is 2. So now what do I have? I have 5 over 3 times 15 times 2. But 3 into 15, we can do that very easily. 3 will go into itself once, and into 15 5 times. So now we have 5 times 5 times 2, which is much simpler than what we started out with, and it's very easy to come up with an answer. 5 times 5 is 25, times 2 is 50. And that would be your answer. Question 4 says, a man invested 5,000 for 9 months at 4%. What is the simple interest? So using this equation where interest equals principal times rate times time over 100, we just plug in the numbers that they give us. So the principal is going to be 5,000. The rate is going to be 4%. This is where the over 100 comes in. So instead of writing 4%, I would do 4 out of 100 times the time, which would be 9 out of 12 months. So now we just go ahead and multiply. So make sure that you simplify before you multiply actually, so that it's easier on you. So there's 2 zeros here and 2 zeros here. You can do that when numbers that end in long lines of zeros. So we have that much down. 4 goes into itself once and into 12 3 times. And now we have 50 times 1 over 10, 1 over 1, the zeros crossed out, times 9 divided by 3 is 3. So essentially we have 50 times 3, which is 150, which is our answer right there. So question 5 gives us m, n, and q, and it tells us that they're in the ratio of 5 to 4 to 3, and it wants us to find the value of 2n minus q over m. It's actually probably more simple than what you would think, because it gives us the ratio of these 3 letters and then gives us an equation using only those 3 letters. We can literally plug in the numbers that they gave us. So remember to keep them in the order. So m is equal to 5, n is equal to 4, and q is equal to 3. So 2n would be 2 times 4 minus q, which is 3, over m, which is 5. Okay, simplify a little bit. 2 times 4 is 8 minus 3 over 5. 8 minus 3 is 5 over 5. And we get our answer, which is 1. So question 6 asks us to simplify these fractions, and they're taken to fractional exponents. So we have 16 over 81 to the 1/4 power. And it's going to be divided by 9 over 16 to the negative 1/2 power. Remember that when you're taking fractional exponents, you're actually taking a certain type of square root, or a certain type of root, I should say. So to the 1/4 power just means the fourth root of what's ever inside here. So we're going to take the fourth root of 16 divided by 81. But remember that when you take something like this inside of a radical, you can split it up so that it'll be the fourth root of 16 over the fourth root of 81. So this goes to this. So here we have this part, and then it's going to be divided by, to the negative 1/2 power would mean to take the square root of each of these and then flip it, because it's to the negative. So remember that when you take something to the negative 1 power, instead of being 9 over 16, it would become 16 over 9, and then it would be to the 1/2 power. Okay, and then so this same idea works for this. This would become the square root of 16 over 9, which is the same thing as saying the square root of 16 over the square root of 9. Remember, it's okay to pull apart square roots if it's multiplication or division, but not addition or subtraction. So fourth root of 16 and fourth root of 81. Okay, so now you just go ahead and do your math. So the fourth root of 16 is 2, and that's because if I were to take the number 2 and multiply it by itself 4 times, I would get 2 times 2 is 4, and then 4 again, and when I multiplied these, I would get 16. So there's that one, and then the fourth root of 81 is 3, because 3 times itself 4 times is also 81. Okay, so we have 2/3 divided by the square root of 16 is 4, and the square root of 9 is 3, because 4 times 4 is 16, and 3 times 3 is 9. So now we have this, a fraction divided by a fraction. Remember that when you divide by a fraction, you can very easily just turn it into multiplication by taking the reciprocal of that fraction. So now we can just go ahead and multiply. These two will cancel each other out. So now we have 2 into 4, which is just 1/2. And that's the answer. So question 7 involves logs, and it says if log base 3 of 18 plus log base 3 of 3 minus the log base 3 of x is equal to 3, find x. So the first step that I would suggest doing is changing this 3 into a log base 3, so that we have log base 3 throughout the entire question. Because there's really not going to be any chance for you to make the log base 3's go away unless you start working over here first. So I'm going to rewrite the first part of the problem. So log base 3 of 18 plus the log base 3 of 3 minus the log base 3 of x is equal to, and it's actually a fairly easy conversion. If we want the log base 3 of something to be equal to 27, sorry, I just said the answer. To be equal to 3, it would be 27. Because 3 to the 3rd power is 27. So that's how that worked out. So if I took the log base 3 of 27, I would get back 3. Okay, so now we have all log base 3's, and it might look more confusing, but actually this is much better for us because since they're all the same log base, we can use the rules of logs to work with these symbols right here. Remember that if you have the same log base and you're adding or subtracting, it's the same as putting it all inside of one of these and multiplying or dividing. So I'll show you what I mean. So I'm going to keep the log base 3. But now I have 18, and I'm going to say times 3. And that's because there's adding right here. Same log base, adding 18 and 3. So the 18 and 3 go here. Then we have another same log base, and we're subtracting, and it's x. So it's going to be over x. And just to make things clearer, I'm going to make this into a dot symbol so that you can see when I mean multiply and when I mean the letter x. And again, this is equal to the log base 3 of 27. So now what do we do? Well, actually now we can just go ahead and get rid of the log base 3. Because since they are the same base, it's just negligible at this moment. So we can do 18 times 3 over x is equal to 27. Now it's much simpler. I'm just going to multiply by x on both sides. So I get 18 times 3 is equal to 27 times x. And then I'm going to divide by 27 on both sides. And I get 18 times 3 over 27 is equal to x. And so now I'm going to simplify as best I can. So what I'm going to do is I'm going to say 3 goes into itself once and into 27. 9 times 27 divided by 3 is 9. And then, so now we have 18 over 9. We'll rewrite it for clarity because this canceled into 1, this canceled into 9. So we all know that 9 times 2 would give us 18. So here we go. X is equal to 2. So here we have question 3, and it asks us to rationalize. And we have 2 minus the square root of 5 over 3 minus the square root of 5. The reason why it asks us to rationalize is because you're not supposed to have something like the square root of 5 in the denominator. And so what we need to do is we need to find a way to get rid of this square root of 5 in the denominator. And the best way to do that is to say to multiply by a version of the denominator that's been modified. And I'll show you what I mean. So we're going to do 3 plus the square root of 5 and 3 plus the square root of 5. So the reason why we did this, instead of saying, see how we took this, is so that we can get a special thing that happens when you multiply two quantities like this. And I'll show you. So 3 minus the square root of 5 times 3 plus the square root of 5. So remember to multiply these. So we have 3 squared, which is 9. And then plus 3 times the square root of 5 minus 3 times the square root of 5. And then minus the square root of 5 times the square root of 5 is just 5. So look at this part right here. These two will cancel because 3 square root 5 minus 3 square root 5 is just 0. So now we have 9 minus 5, which is 4. So that's a much easier thing to work with, and it gets rid of these on the denominator, which we don't want. Okay, so I did the multiplication on the bottom half. We said it was 4. So that helps us eliminate two answers so far, right? Let's keep going. So now we're going to do the top part. So 2 minus the square root of 5 times the quantity 3 plus the square root of 5. So we do the same process, right? So 2 times 3 is 6. 2 times the square root of 5 is 2 root 5. This is minus 3 root 5, and this is minus 5. So let's combine like terms where we can. So 6 minus 5 is just 1. And then these are like terms as well. So 2 root 5s minus 3 root 5s would just be negative 1, or I'm going to say minus root 5. So 1 minus root 5 on the top. And that's your answer. So here we have question 9, and it says simplify. And it gives us two quantities. We have the quantity the square root of 2 plus 1 over the square root of 3, and the square root of 2 minus 1 over the square root of 3. So this is fairly straightforward. We're just going to use the FOIL method. So let me write that out for you. FOIL. And so this is the method that I've been using when I multiply two quantities. It's first, outer, inner, last. So the first two are the square root of 2 times the square root of 2, which would just be 2. And then we're going to move on to the outer. So that would be these two. So the square root of 2 minus, sorry, we have negative 1 over root 3 times the square root of 2. So I'll rewrite that down here. Root 3 times the square root of 2. So that would just be negative root 2 over root 3. So I'm going to write that right here. So it's going to be minus the square root of 2 over the square root of 3. Then we move on to the inner terms, which is these two. So this time it's going to be positive square root of 2 over square root of 3. And then we do the last two terms. So 1 over the square root of 3 times negative 1 over the square root of 3. I can pull out a negative, and then I would say like this, 1/3 times, 1 over the square root of 3. So these would just become, remember you multiply straight across, so 1 times 1, you get negative because of the negative here. So we get negative 1 over the square root of 3 times the square root of 3 is just 3. So we get minus 1/3. So notice here, when you combine like terms, that we have negative root 2 over root 3 and positive root 2 over root 3. So if I were to take negative 2 and positive 2 and add them, I'd get 0. The same thing happens here because these are the same numbers. They turn into 0 because one's negative and one's positive. So we're left with 2 minus 1/3. And then to make it easier on ourselves, we can make this 2 into a fraction. And so the way we would do that, so we need to change this into a fraction where it has a denominator of 3. And there's two ways I can think of doing this. So you would say 2, and then you would want it to be over 3. And so right now it's 2 over 1, and we want whatever it is over 3, right? So you would say, well, I multiplied this by 3 to get 3, right? 1 times 3 is 3, so 2 times 3 is 6. And then another way you could think about it is, well, the number 1 means we have a whole. If we have another 1, that would give us 2, so we have 2 wholes. If we're thinking in terms of thirds, then that would be 3/3 plus 3/3, which is 6/3. Okay, so the point is we have 6/3, and we're going to subtract 1/3. So what do we get? We get 5/3. So here we have question 10, and it says from the Venn diagram above, it means the one right next to it actually, the complement of the set PQ, P intersection Q, is given by, and then it gives us some options. So first let's review what intersection means. So here we have the intersection symbol, and intersection, well, I'll also use union to explain this to you. Okay, so here is union, U-N-I-O-N, intersection, I-N-T-E-R-S-E-C-T-I-O-N. Okay, the union has to do with the inclusion of sets. And so let's say I had two sets. And the first set consisted of the numbers 1, 2, and 3. And the second set consisted of the numbers 3, 4, and 5. A union of these two sets would be 1, 2, 3, 4, and 5. Why is that? Well, that's because with a union, you're going to include everything in both. And if you have something that is common, then you only count it once. And so it can be related to, like, say, a marriage. In a marriage, if one person has so many things and the second person has so many things, then you just combine them. And so I'll give you an example using not numbers. So let's say there's a blender, a stove, and a vase. And let's say the second person also has a vase, but they also have a microwave, and let's say they also have a mop. Okay, in the union of these two people, they will now have a blender, a stove, a vase. Now technically they have two vases, but let's just say that there's no need, like let's say you were taking, I don't know, inventory of what they had, you wouldn't need to count the vase twice. You just wanted to know what they have. It's not necessary. So just like we didn't count the 3 twice, we're not going to count the vase twice. So just the vase, and then a microwave, and a mop. This would be the union of the two. Alright, so now let's focus on intersection. What does intersection mean? So using the numbers, oh my goodness, I'm having trouble with this. So using the numbers, there's one set, 1, 2, and 3, and then we have a second set, 3, 4, and 5. What is the intersection of these two? Well, you can think of this sort of like two lines. Okay, you have a coordinate plane, you have a line that looks like this, and you have another line that looks like this. Where did these two lines intersect? Well, they intersect right here. This would be the only point that you would count. So where do these two sets intersect? Right here. So this would be the only point that you count. So the intersection of these two sets, if I can draw an intersection symbol, a set symbol, the intersection of these two sets will just be the number 3. And just so you know, an intersection doesn't always only include one number or one thing. An intersection can include more than one thing. So I'll go ahead and use numbers still for an example. So let's say this time I had the set 1, 3, 5, and 7. And in this set I had the numbers 2, 3, 4, and 5. The intersection of these two would only include the numbers that they have in common. So they have in common a 3, and they have in common a 5. So the intersection of these two would be 3 and 5. And again, you don't count repeats. You wouldn't write 3, 3, 5, 5. It's just 3 and 5. Okay, so now that we've gone over that, let's go back and, oh wait, there's one more thing I really need to show you before we can answer this question. So you see here it says the complement. This is the complement of the set P intersection Q. Okay. Okay, before I move on and teach you what the complement is, let's think P intersection Q. What does that mean? What is P intersection Q? Okay, P is referring to this circle, and Q is referring to this circle. So P includes B and C, and Q includes C and D. So I'll write that out. I'm just going to switch to a new color now. Okay. The set P contains B and C. The set Q, no, that's the same color I've been using. The set Q includes C and D. What is the intersection of these two? Well, just like before up here, we looked where do they have a number that's in common, and we called that the intersection. We're going to do the same thing over here. Where do they have something that's in common? Well, only C. The only thing that they have in common is C. So the intersection of these two, so P intersection Q is equal to C. That's it. C is by itself. It's its own set. So now we need to know what the complement of this is so that we can figure out the answer. Okay. Let's learn about the complement. Okay, it is within E. So now we have this thing called the complement. So what will happen is, and I'll show you using this. Okay, I have here a rectangle. This is the one space that I am concerned about. And inside of the rectangle, I have two different things. I have this circle and the rest of it, the rest of the rectangle. So I'll call this circle A. The outside of the circle that's still included in the rectangle is A prime. Here. There's another color for that. So let's see here. Where is it? Was it? No. Sea green. Okay. This is all. This is A. And then, oh, there we go. Everything out here that's still in the rectangle, but outside of the circle of A, is A prime. And this just happens to be a notation that they have. Or like it happens to be a result of notation. So I'll show you what I mean. So A and A prime, they complete each other. They complete this rectangle. So that's why A prime is called the complement of A, because this A prime is the complement of A. So, in terms of probability, the probability of, say, landing in the space A, if you're going to throw a pebble or something, the probability of landing in the space A plus, and I guess I could use my color coding that I've been doing, this would be, plus the probability of landing in space A prime would be equal to 1. Okay, so because when they add up, they fill the entire space. So the complement means the thing that completes the other. So going back to this, we have to consider this rectangle. Okay, and it has two circles in it. It has two circles in it. Okay, we're going to pretend that, well, I'll try again with drawing these circles. Oh, that's terrible. One more time, and then if I don't get it, we'll just move on. Okay, well, I'll do one more time. There, that's good. Okay, so here we have two circles. One of them is called P, and one of them is called Q. And then we have these points of interest, you could say. There's lowercase b, lowercase c, lowercase d, lowercase a, and lowercase e. So we already decided that the set of P intersection Q is only C. So this is sort of the first thing that we're interested in. And then it says, from the diagram, the complement of this set. So what completes this picture to complete the rest of this rectangle? What else do we have to include? Well, we have to include B and D, because that fills up part of the rest of the rectangle, right? We also have to include A and E, because that also fills up the rest of the rectangle. P and Q aren't points of interest, they're just labels for these circles, so we don't include them. So the complement of P intersection Q would be the set A, B, D, and E. And that's the answer. So here we have question 11, and it says Relia has 7 different posters to be hung in her bedroom, living room, and kitchen. Assuming she plans to place at least a poster in each of 3 rooms, how many choices does she have? So this problem is going to, well, it's going to require us to do a little bit of thinking. So first off, she has 7 posters, right? 7 posters. And she has 3 rooms to choose from. But more than that, she can put more than 1 poster in the room. 7, choose 3 plus 1. Okay, so the way that you do that is you just do 7 factorial to account for different combinations of posters, over 3 plus 1 is 4 factorial to account for the different ways they can be arranged. You don't want to over account, so you have to divide by them. And just remember that 7 factorial is the same as multiplying 7 down, so you have 7 times 6 times 5 times 4 times 3 times 2 times 1. And then you do 4 times 3 times 2 times 1 to represent 4 factorial. This will cancel, this will cancel, this will cancel, and this will cancel. So you're just left with 7 times 6 times 5. So let's figure out what that is. 6 times 5 is 30. So 7 times 30. Well, we'd put the 0 down, and then 3 times 7 is 21, so we'd have 210. 210 options. So here we have question 12, and it says make R the subject of the formula if t is equal to k r squared plus m over 3. So I'm going to rewrite this. So I would start by multiplying by 3 on both sides so that I can start isolating R. These would cancel, so I'm left with 3t is equal to kr squared plus m. So now what can I do? Well, I can subtract m from both sides. So I'm left with 3t minus m is equal to kr squared. We're very close, but now we need to divide by k on both sides of the equation so that we can get r by itself. So 3t minus m over k is equal to r squared. Now we have one more step that we need to do, and that's take the square root. So if we take the square root of both sides, then we'll be left with r is equal to the square root of 3t minus m over k. So when you go up and look for the answer, you'll see that that's not an option, and so what you would do is you would leave this blank because they do not list the correct answer. Okay, so here we have question 13, and it says find the remainder when x cubed minus 2x squared plus 3x minus 3, so I'll write that out, x cubed minus 2x squared plus 3x minus 3 is divided by x squared plus 1. And so they're asking for the remainder, so just keep in mind that the remainder would be, for instance, if I were to say 7 divided by 2, well, that would be 3, or at least that's as close as I could get. So 2 times 3 would give me 6, and then I would say it has a remainder of 1. And so this remainder, because if you have this remainder right here, would be our answer. So we're going to get a remainder when we do this long division over here, and that will be our answer. Okay, so remember that when you want to do long division with polynomials, you only pay attention to the first number. So what would you do to get x squared to equal x cubed? Well, you would multiply by x. And so then you would do, the next step that you do is you say x times x squared is x cubed, and x times 1 is just x. And I'm going to put that over here. And so what happens is I get these placeholders of 0. And so the reason why I put those there is because when I multiplied x times this, there was no x squared value that I had. So there's not going to be anything that I'm going to be able to subtract over here. The same thing happens here. There's no value of just a constant number that I get to subtract. So I'm going to put in my placeholder 0, and it's okay to do that because adding 0 doesn't do anything to it. So x cubed minus x cubed is 0. Negative 2x squared minus nothing is negative 2x squared. And then 3x minus x is going to be 2x. And negative 3 minus nothing is negative 3. So now we do the process over again. X squared going into negative 2x squared. Well, that would just be negative 2. Because negative 2 times x squared would give us negative 2x squared. Okay, so now let's multiply negative 2 by this entire thing. So we're going to get negative 2x squared, and then negative 2 times 1 is negative 2. And again, I'm going to put that here so I can line up my values. So the x squared is underneath the x squared, the constant number is underneath the constant number, and then I'm going to put a placeholder right here because I have nothing to subtract from 2x. So when I do my subtraction, I'm going to have a negative 2x squared minus a negative 2x squared. So remember that a negative minus a negative is just like adding 2x squared to this negative. So this would cancel out and be 0. 2x minus 0 is just 2x. And negative 3 minus negative 2 is like saying negative 3 plus 2. And so I have minus 1. So now I've gotten to the point where I can't get to x, or I can't get x squared to fit into 2x. So this is my remainder. So that's going to be your answer, 2x minus 1. So question 14 asks us to factorize completely. And it gives us 9y squared minus 16x squared. So the first thing that you need to do is realize that this is the difference of squares. And so what I mean by that is, say I had x plus 3 times x minus 3. what I would get is I would get x squared minus 3x plus 3x minus 9. So this would just be x squared minus 9. So if you ever see x squared minus 9 and they ask you to factorize completely, you should know that this is just a difference of squares. So you would factorize it out to x plus 3 and x minus 3. So you can recognize the form over here. They've just made it a little bit harder by adding in a y squared, and you have to figure out, and coefficients on the variables, and you have to figure out where it came from. So first off, we can tell that 9 and 16 have easy square roots. So 9 is the same as saying 3 squared, y squared here, and then this is the same as saying 4 squared x squared. And so now we're at this point. So what we did here was we split up the x squared. You see that? X and x. So that they multiply to it. So here I'm going to have two quantities, and I'm going to say 3y on both sides. So that's what we did over there. And then they split up the negative 9 into its two constituents, so that would be positive 3 and negative 3. So we're going to do the same thing with this one. We're going to say plus 4x and minus 4x. And that's it. That's your answer. So question 15 says solve for x and y respectively in the simultaneous equations negative 2x minus 5y is equal to 3 and x plus 3y is equal to 0. So I'm going to start by lining up these two equations. X plus 3y is equal to 0. And I'm going to use them in a system of equations. So what I want to do is I want to find a way to manipulate either one of these two so that I can start canceling one variable and solving for another. So the best option that I see right now is to multiply this second equation right here. Multiply this by the number negative 2. And so I'm going to say times negative 2, and I'm going to rewrite what I have. So I still have the top part the same. Negative 2x minus 5y is equal to 3. And then the bottom equation, negative 2x, I'm going to say minus 6y. Actually, I'm going to make this a positive 2. That'll make our math a little better. So then we're going to have 2 times 3 is positive 6y is equal to, well, 2 times 0 is just 0. So now I'm going to say to add these two. Okay, so what happens is that the negative 2x and the 2x add up to 0. Sorry, that was just 0. And then negative 5y plus positive 6y is just 1y. And this would be 3 plus 0 is 3. So now here we go, y is equal to 3. So we're part of the way there. Now we need to plug this in to one of the equations from above. So I'm going to plug it into this equation. So we don't have x yet. X plus 3 times y we do have. So 3 times y would be just 3 times 3 is equal to 0. Okay, so that means that x plus 9 is equal to 0, or x is equal to negative 9. Awesome. So now what? Because if you'll notice, the answer gives it in this form. It gives it in an ordered pair form. So remember that ordered pairs come in the order x, comma, y. So it's going to be negative 9, comma, 3. That's your answer. So here we have question 16, and it says if x varies directly as the square root of y, and x is equal to 81 when y is equal to 9, find x when y is equal to 1 7/9. So the first thing we need to do is set up an equation that we can use so that we can plug in this. So let's set up that equation. We know that x varies directly as the square root of y. So this symbol means that x has some sort of direct proportionality to y, and so we're going to represent that direct proportionality as k, where k is a constant. So now what we want to do is solve for k using the two numbers that they gave us here. So x is equal to 81 when y is equal to 9. So we know that the square root of 9 is 3, so 81 is equal to k when, excuse me, 81 is equal to k times 3. So now let's divide by 3 on both sides. And I'm pretty sure it's 27, but I'm just going to check my math over here. So 3, 27, 3 times 7 is 21, and yes, okay. And then we get 81. Okay, good. So here we have 27 is equal to k. Okay, so let's go back to this right here. So now we know k, so we can make this sort of a law connecting these findings that we have found. So x is equal to 27 times the square root of y. And so now we want to know what happens when y is equal to 1 7 ninths. What is k? So y is equal to 1 7 ninths. Okay, so 1 times 9 is 9, plus 7 is 16. So this is the same thing as saying 16 over 9. So now I'm going to say x is equal to 27 times the square root of 16 over 9. Remember that when you're taking a square root and you're doing division inside of it, you can separate your values. So this will be the square root of 16 and this will be the square root of 9, as long as you're still dividing. So this is x is equal to 27 times the square root of 16 is 4, and the square root of 9 is 3. So you know that 27 can be divided by 3. So 3 would cancel into 1, and 27 would become 9. So x is equal to 9 times 4, which is 36. Alright, so question 17 tells us that t varies inversely as the cube of r. So when it says inversely, what it means is it's going to be 1 over r cubed, because it's the cube of r. So we can make this into an equation by using a constant, because it varies in a constant way over r cubed. So then it says that when r is equal to 3, t is equal to 2 over 81. So let's plug that in. So 2 over 81 is what t is equal to, and then we're going to leave q because we don't know that yet, and r they said was equal to 3. So now we solve for k. I think I called it q a few moments ago. I meant k. What I want to do is I'm going to divide by k first. So I'm going to say times 1 over k on both sides. So these will cancel. Oh, and by the way, this is cubed. 3r cubed, so this is 3 cubed. So now I'm going to have 1 over k times 2 over 81 is equal to 1 over 3 cubed, which is 27. I'm going to take 2 over 81 and I'm going to put it over here, and the way that I'm going to do that is I'm going to say times 81 over 2. So then this would cancel, and I'm left with 1 over k is equal to 1 over 27 times 81 over 2. So 27 goes into itself 1 time and into 81 3 times. And so I would be left with 1 over k is equal to 1 times 3 is 3, and 1 times 2 is 2. And then so I'm going to take the inverse of both of these so that I have k is equal to 2/3. So there, so far we've solved for k, so let's put it back into this that we had here. So we have t is equal to k, which is 2/3, divided by r cubed. And they want to know what t is when r is equal to 2. So we're going to have t is equal to 2 over 3 times 2 squared, cubed. And so the way I can do that is because it's 2 over 3 and then over something else is the same as saying 2 over 3 times that something else. So now we know t is equal to 2 over 3 times 2 cubed, which is 8. So t is equal to 2 over 3 times 8 is 24. And then 2 over 24, well, that reduces to 1/12. So t is equal. So here we have question 18, and it says, which of the following diagrams represents the solution of inequalities? Y is less than or equal to x minus 2, and y is greater than or equal to x squared minus 4. So essentially what we want to do is, let's see if I can sort of map this out for us. There we go. Okay. So for the equation, let's focus on the equation y is equal to x minus 2 before we start thinking about the inequality for it. So we know that from the y equals mx plus b, I'll write it below, y equals mx plus b. So b is going to be our y-intercept, which is -2. So we're going to go down 1, 2. This is our y-intercept. And m is our slope. We have a slope of +1. So we're going to go over 1 and up 1. And it's going to continue this pattern. And so I'll use the line tool to help me draw a line here. So this is y is equal to x minus 2. Now we have this other curve, and this one is y is equal to x squared minus 4. And you'll see here that all of the pictures are the same for at least for the drawings of the lines themselves. And so we can trust that the line of x squared minus 4 will look like this. And I'll show you why in a moment. Or here, I'll show you why first, actually. So y is equal to x squared minus 4. That is the same as saying x plus 2 times x minus 2. Okay, so our y-intercept, I hope if I'm remembering this right, should still be at -4. But now we have this issue of zeros. It was easy to find the last zero just by going up 1 over 1, up 1 over 1. And we saw that it hit right here at the point 2, 0. Over here, our zeros are going to be when x is equal to -2 and when x is equal to +2. So that means it's going to hit again here and also out here at -2. And then it's going to go, it's going to look something like this. It could be wider if I had made the distance between my points wider, but essentially this is what we're looking at. And now we want to see what the inequalities say. So it says y is less than or equal to x minus 2. So here is the line y is equal to x minus 2. So what happens when we only look at values underneath this, right? So less than this line would be down here. It would be all of this. Everything below the line would satisfy less than or equal to x minus 2. And now let's look at the other one. It says greater than or equal to the line. So anything greater than or equal to x squared minus 4. Well, this is the line, and I didn't label it. This is y is equal to x squared minus 4. That's this curve. What is greater than or equal to this line? Well, that would be everything here, and also everything in here. And so the only place that would satisfy both of these equations would be this section right here. So the answer then would be A. Okay, so here we have question 19, and it says to solve the inequalities, and it gives us negative 6 times the quantity x plus 3, negative 6 times the quantity x plus 3 is less than or equal to 4 times x minus 2. So the first thing that we're going to do is distribute this negative 6 and this 4. So it's going to be negative 6x plus negative 6 times 3 is 18. Then in parentheses is less than or equal to 4x minus 8. Okay, so the next thing that we're going to do is we're going to start isolating x. So with that, what that means is that I'm going to put this 4x on this side, and I'm going to move this negative 18 over here. So it's going to be negative 6x minus 4x, because I subtracted 4x from both sides, is less than or equal to positive 18, because I add 18 to both sides, minus 8. So now we have, we can combine like terms. So negative 6x plus negative 4x is negative 10x, is less than or equal to 18 minus 8 is 10. So now we have negative x is less than or equal to 1. So, and all I did was divide by 10 on both sides. And so now I can divide by negative 1. But remember that when you divide by a negative number and you're working with inequalities, you're going to have to change the sign. So instead of being less than or equal to, now it's greater than or equal to, and this is negative 1. So x is greater than or equal to negative 1. Alright, so question 20 asks us to solve the inequality, and it gives us x squared plus 2x is greater than 15. So because of this whole x squared and, well, mostly because of the x squared thing, it's not going to be as simple as isolating the variable, because we can't combine x squared and 2x. So what we have to do is make this into something that we can pull apart. So I'm going to subtract 15 from both sides. So now we have 0 over here. And what I mean by pulling it apart is we're going to find two quantities that can be multiplied to get this up here, and it'll make it easier for us to solve for x. So x squared will be given to us by an x here and an x there. And then we want something that can multiply to negative 15, but will add up to positive 2. And this works because of the way what happens when you multiply quantities like this. So if I have x plus 2 and x minus 5, what will happen is I'll get x squared minus 5x plus 2x minus 10, which will leave me with x squared minus 3x minus 10. So what happened was I had two numbers that multiplied to negative 10 and added up to negative 3. So that's the thing I'm trying to do here. I want two numbers that multiply to negative 15 and add to positive 2. And so well, two numbers that could easily work here are 3 and 5, because we know that 3 times 5 is 15. And if we change one of these to be negative, we'll get negative 15. And so I'm going to say that we change the 3 to a negative 3. So we're going to put minus 3 plus 5. And so what happens is if you were to check this and multiply it out, we'd have x minus 3 and x plus 5. And so you would get x squared plus 5x minus 3x minus 15. So then you'd have x squared plus 2x minus 15, which is what we wanted up here. Okay, so now that we have that, I can get this to go away. Okay, so now we're going to say, so what would happen if we had said x minus 3 quantity times x plus 5 quantity is equal to 0, and we were solving for x? Well, we would say x is positive 3 over here, and x is negative 5 over here. Is equal to. But that's not what we're trying to do. We have an inequality instead. So the thing to change will simply be the inequality. Or sorry, this instead of an equal sign, we're going to have this, a greater than sign. So x is going to be greater than 3, and x is going to be greater than negative 5. And so you can, basically what I did was I changed the sign. So instead of negative 3, it became positive 3. Instead of positive 5, it became negative 5. And so that happens because if we were to take these like this, and then just add 3 to both sides, you'd say plus 3, we'd have x is greater than positive 3. So that's where that came from. And you can do the same thing for the other one. So we have this, x is greater than 3, and x is greater than negative 5. So what happens is x is going to be, let me see here. Let me see. So you're going to have, it's going to be like this. You're going to have 3 on this side and negative 5 here. So what we did was we placed x between negative 5 and 3. And so your answer would be B. 21 asks us to find the sum of the first 18 terms of the series that starts 3, 6, 9, goes all the way up to 18, all the way up to 36. So the way that you want to do this is you want to use this equation. It'll get you to your answer much faster than having to figure out what the first 18 terms are and then adding them all up. So what happens in a series, in an arithmetic series where you're just going up, adding, well, basically you're going to have n, which is your number of terms. And I'll write this over to the side. So n equals your number of terms. A is your first term. And D is the difference, or the common difference. So basically what happens is, as long as you know this formula, it's fairly simple to get to the answer. So you're going to have n is the number of terms you want to find. So 18, they said, what's the sum of the first 18 terms? And we're going to leave it over 2 times the quantity. 2 times A. A is going to be our first term, so that's 3. So 2 times 3 plus n, which as we said was 18, minus 1 times D, the difference. Well, we can see it's going up by 3 each time. 3 plus 3 is 6. 6 plus 3 is 9. So times 3. So now that we have that, we can start simplifying so we can come up with an answer. So 18 divided by 2, well, that's 9. 2 times 3 is 6. 18 minus 1 is 17 times 3. I don't know 17 times 3 off the top of my head, so I'll do the math here. 3 times 7 is 21. Put down the 1, bring up the 2. So this will be 3 plus 2 is 5. So we get 51. 9 times the quantity 6 plus 51. And so then we're going to add, and we're going to get 9 times the quantity 6 plus 51 is 57. And then we're going to do 9 times 57. Same process. 9 times 7 is 63. 9 times 5 is 45 plus 6. 45 plus 6 should be 51. So our answer looks like it's going to be 513. And that would be B. So question 22 asks us, or it tells us that the second term of a geometric series is 4, while the fourth term is 16. Find the sum of the first 5 terms. So essentially what's going on here is we have a geometric series, and we know that the second term of the series is 4, and that the fourth term is 16. And when they say geometric, that means that something is being multiplied, either a whole number or a fraction, and it's causing the numbers to, at least by appearances, it seems it's causing the numbers to increase by some sort of factor. So what we need to do is first off figure out what the starting term is. And so to do that, we need to use this equation, a times r to the n minus 1. So what does this equation mean? Well, the first term in a geometric sequence is referred to as a. So our first term, which we don't know yet, is a. And then the r stands, that would be the rate of change. And then n minus 1, n is your number of interest. So I'll show you what I mean. So a times r is equal to 4. And so the reason why I wrote it like this is because this is the second term in the sequence. So you write it down. We know that it's the second term. So technically what's going on here is we have 2 minus 1 as our exponent. But 2 minus 1 is just 1. And r to the 1 power will again just be r. Okay. What else do we know? We know the fourth term, which is 16. And so this time we're going to say a times r cubed, because it would be r to the 4th minus 1. And 4 minus 1 is 3. So we know these two things, but how is this going to help us find a or r? So the way that we need to do this is we can set up a ratio. We can say if ar cubed is equal to 16 and ar is equal to 4. We can set up this ratio here. If I can get all these little lines to go. So if we set up a ratio between these, we'll get something that we can work with. So the a's will cancel, and at least one of these r's will cancel. So we're going to have r squared is equal to 16 divided by 4 is 4. So now we know that r is 2. And so that means that that's going to be our rate of change. But we still don't know the first term, which is necessary if we want to know the answer, which is find the sum of the first 5 terms. And so the sum is going to be given to us by using this equation, which, if you'll see, it requires us to know what a is. So going back, we can use this to plug back into one of these equations and figure out what a is. So a times 2, we'll put that in for r, is equal to 4, which means that a is equal to 2. So now we know what our first term is. And so this is actually what it would look like. It would look like 2, then 4, then 8, then 16. And each one of these is being multiplied by 2. So now what we have to do is find the sum of the first 5 terms. And so what you could do is say, well, now I know the sequence, I can just come up with the first 5 terms and add them up. that's fine if it's faster for you. Or if you know the equation well, you can also just plug in the terms that you know. So our sum is going to be equal to 2, because that was our first term, times r to the n. We know that our rate is 2, so that will be our r. N is our number of interest, so first 5 terms, so it's going to be 2 to the 5th power minus 1 over r, which we know is 2 minus 1. So we go ahead and simplify, and we're going to have 2 times 2 to the 5th power. Well, let's figure out what that is. 2 times 2 times 2 and times another 2. 1, 2, 3, 4, 5. Good. So we'll have 4 times 4 times 2. 4 times 4 is 16 times 2 is 32. Okay, so we'll have 32 for the 2 to the 5th, minus 1 is 31. And it's all going to be over 1, because 2 minus 1 is 1. So now we just have, well, I'll write it down here. Now we just have 2 times 31, which is 62. And that's our answer. Alright, so 23 says a binary operation, and it gives us a symbol, and it looks like this, on two real numbers is defined by x symbol y. And it tells us that what this really means is xy plus x plus y for two real numbers x and y. And then it tells us to find the value of when we perform this operation between 3 and negative 2/3. So we just want to follow their directions. So it's 3, then our symbol, then negative 2/3. So what they say is that what this means is to say that assume that this is x and this is y. Because as you saw, it looked like this. So then we're going to manipulate x and y with this that they gave us here. So it says to take x times y plus x and then plus y. So that's exactly what we're going to do. We're going to take 3 times negative 2/3 plus x, which is 3, plus y, which is negative 2/3. So we can simplify a little bit now. So 3 times negative 2/3. Remember that the whole number 3 can be rewritten as the number 3 over 1, because anything divided by 1 is itself. And now you can cancel these 3's. And so all we're left with is negative 2 over 1, which is just negative 2. It's going to be plus 3, and then we can just say minus 2/3. Simplifying even further, we have negative 2 plus 3 is positive 1 minus 2/3, and our final answer is 1/3. So question 24 wants us to find x, and it gives us these matrices. Okay, so the way that you want to do this is you want to first, you're going to do the same process to both of these matrices, and we're basically going to get it to a more linear form. So what happens is we're going to take 3x times 2, which is 6x, minus 5 times 3, which is 15. And then we do it on the other side as well. So we follow the same pattern. So last time we took the bottom right and multiplied it by the top left. So we're going to do that first here too. So 4 times 2x is 8x. And then we're going to subtract the other diagonal, which is 3. Now we're going to start isolating for the variable. So I'm going to move this 8x over to this side by subtracting 8x from both sides. So now I'll have 6x minus 8x minus 15 is equal to negative 3. Now I'll add 15 to both sides to get rid of this 15. 6x minus 8x is equal to negative 3 plus 15. Then I'll have negative 2x is equal to 12. Then I can divide by negative 2 on both sides, and x is equal to negative 6. And that's your answer. So question 25, this is this sort of 3 by 3 block, and it has the numbers 4, 2, negative 1, 2, 3, 1, negative 1, negative 1, and 3. And it wants us to evaluate. So what we're going to do, and I'll use another color to show what I'm going to say. So this top row, the 4, 2, and negative 1, we're going to split that up. So we're going to have 4 and 2 and negative 1. And we're going to split up these bottom 2 rows in this specific way that I'll show you. So we're going to take this box of numbers, the 3, negative 1, 1, and 3. Now I'll take away that line so it doesn't get sloppy later on. And we're going to make them into a smaller one. So 3, 1, negative 1, and 3. I'm going to say plus, and then we're going to do the same thing with this 2, but instead of taking that block of numbers, we're going to take these and these. And we're going to line them up as you see them. So it'll be 2, negative 1, then 3. So I'll take away those and write them over here. So 2, negative 1, and 3. And then plus this minus negative 1. And we're going to do the same thing, but this time it's going to be this block of numbers. And it's always done in this order. So now we're going to take 2, negative 1, 3, and 1. Okay. So I'm going to go ahead and simplify a little bit. So plus a negative number is just like saying subtracting that number. So okay. And now we can do some simplification with each of these smaller matrices. So what you want to do is you're going to take 4 times this diagonal minus this diagonal. So 3 times 3 is 9, minus 1 times negative 1 is negative 1, plus 2, and then we're going to do the same process. 2 times 3 is 6, minus negative 1 times negative 1 is positive 1. And then minus, because there's a minus here, 1 times 2 times 1 is 2, minus 3 times negative 1 is negative 3. So we go ahead and simplify some more, and we'll have 4 times, this is 9, when you subtract the negative number, so here we have 4 times 10, plus 2 times 6 minus 1 is 5, minus 1 times 2 minus negative 3 is 5. So now we multiply out those numbers so we can get our answer. So 4 times 10 is 40, 2 times 5 is 10, and 1 times 5 is just 5. So 40 plus 10 is 50, minus 5 is 45. And that's our answer. Question 26 wants us to find the inverse matrix of n when n equals 2, 1, 4. And it gives us a few options. So, how do we find the inverse of a matrix? There's a certain process that we want to follow. And so basically, the inverse of a matrix will, so we'll say n minus 1, or excuse me, n to the negative 1 power, because this is how you write the inverse of a matrix, is going to be equal to 1 over the determinant of n times a slightly modified determinant, or excuse me, slightly modified matrix. So the first matrix, let's assign the first matrix the numbers. It's going to be A, B, I'll go in this order, C, A, and D. Or, here. Already did this. Let's just go away. Okay. I'll put A and B here, C and D there. Okay. So essentially what you want to do is you want to swap the places of A and D and put negative signs in front of B and C. So if the original numbers are 2, 1, 3, and 4, we're going to swap their places. So I'll write it up here. So this will become D, A, negative B, negative C. So this is going to change into 4 and 2, negative 3, and negative 1. So now all we need to do, since we know this part already, is we need to find our determinant. Although you could figure that out by sort of taking a look here, and we're going to see that our determinant is probably going to be 5. And so let's figure that out, just to be sure. 2, 1, 3, and 4. So to find the determinant of a matrix, like this one, what you want to do is you want to multiply this diagonal. So 2 times 4 is 8. And then you're going to subtract by the other diagonal. So 3 times 1 is 3. 8 minus 3 is 5. So this is our determinant. So that means that our inverse is going to be 1 over 5 times this part that we identified earlier. 4, negative 3, negative 1, and 2. So this is going to be your answer, which is this one right here. Question 27 says, what is the size of each interior angle of a 12-sided regular polygon? And then it gives us some options. So I've written here the equation that's used to get, it's used to get the sum of all of the degrees inside of a certain regular polygon, and it has to be a regular polygon. If you were to divide by n, that'll give you the total, or that'll give you the degrees for each individual angle. And so I'll show you what I mean. So we have a 12-sided regular polygon. So that means 12 is n. And if we take 12 minus 2 times 180, that should give us the sum of all of the degrees inside of that regular polygon. So 12 minus 2 is 10 times 180 is going to be 1,800. And then if we take this 1,800 and divide by 12, that should give us what each angle is. Because if it's a regular polygon, all of the sides are the same and all of the angles are the same. And so when I do this step, this is the same thing as what I wrote over here. I'm dividing by n to figure out what each angle is. 1,800 divided by 12 is going to be, it's going to be 150. But if that doesn't come naturally to your mind, you can always try out a few of these options, or just look at them and think what sounds reasonable. I don't think 12 times 30 would give me 1,800 very quickly, and we just saw that 10 times 180 would give us 1,800. So 12 times 180 is not going to give us that, so that would easily cross out those two, and then you could try either of these two, or you could just try your hand over here. You could say 1800 divided by 1, 2, and then you could say 12 and 2, 18 would be ones, and you would subtract and get 60, and we know that that's 5, and then that would be your answer. So there's a few ways to arrive at the answer, but the idea is that 150 degrees will be your final answer. Question 28 tells us that if a circle of a perimeter of 28 centimeters is open to form a square, what is the maximum possible area of that square? And essentially, what they're asking you to visualize here is, say we took a circle and we somehow like split the circle and we're able to make it into a square. What is the maximum possible area? So that's going to actually be defined in a way by the perimeter. So we know that the perimeter of the circle is 28 centimeters. So that means that the distance around the circle is 28. That means that the distance around the square can only be 28. It's not going to get any larger, and there's really no reason for it to get any smaller either. So this also has a perimeter of 28 centimeters. Since it's a square, we know that all of the sides, every length of the square, are exactly the same. So we can take 28 and divide it by its 4 sides to figure out what each side measures. So 28 divided by 4 is 7. So now we know that every side of the square is 7 centimeters. Now it's fairly simple to find its area. We just take 7 times 7, because to find the area of a square, you multiply its 2 sides, and we get 49 centimeters squared. That's our answer. Question 29 says, a chord of a circle of radius 7 centimeters is 5 centimeters from the center of the circle. What is the length of the chord? So what's happening here is we have a circle, and it has its center, and there's a chord or a line going through the circle at some point. We'll just say it's right there. And the circle has a radius, a full radius of 7. So that means that if I go from the center to the edge of the circle, that's 7 centimeters. And the chord said is 5 centimeters from the center of the circle. So that means that this distance is 5 centimeters. So, and let me draw a different chord to make this a little bit more visible, what I'm trying to show you here. That means that the center, if the radius is 7 centimeters, that means that from the center to any edge of the circle, it's 7 centimeters. So this line would be 7 centimeters, as well as this new diagonal line that I just drew. That would also be 7 centimeters. So see if I can get this to go away. Okay, that's 7 centimeters as well. What they are interested in is the full length of this chord. We'll call it chord AB. They're interested in the length of this chord. We can easily find the length of half of the chord, because this will form this perpendicular bisector right here. And so once we find the length of this, we can find the length of this, and we can add the two. So we see we have a right triangle, and so we know by Pythagorean's theorem that it will be 7 squared will be equal to 5 squared plus this missing side, which I'll go ahead and call it x, plus x squared. So we can solve for x by taking 49, which is 7 squared, minus, because I wouldn't have subtracted this, 5 squared is 25. It's going to be equal to x squared. So 49 minus 25 is 24, is equal to x squared. And so we can take the square root, and we'll ignore a negative answer because that won't make sense in the context of this. So we're going to say that it's going to be, and so remember that when we take the square root of something, we can't, working with just the square root of 24 isn't enough. We can still simplify this a little bit more. So we need to find two numbers that multiply to 24, but at least one of them can be taken the square root of. And so that what comes to mind is 4 and 6. 4 times 6 is 24, and we can take the square root of 4. So I can rewrite this like this. Square root of 4 times the square root of 6. The square root of 4 is 2, and we can't take the square root of 6. So here we are. We're halfway there. This is what this length x is. But the chord AB is not just x, it's 2x. So all we have to do is say 2 times 2 root 6, and we get 4 root 6, and that's our answer. So question 30 says, a solid metal cube of side 3 centimeters is placed in a rectangular tank of dimensions 3, 4, and 5. What volume of water can the tank now hold? So what's going on here is we have a rectangular tank, and I'll see how good I can draw this out for you. And let's just say it looks something like this. So this is our tank. And they said it was 3, 4, and 5. So I'll just label this 3, this 4, and this 5. And then they told us that we have a solid metal cube. So I'll draw as best I can. Okay. Pretending that these lines are straight and not curved as I do them. So I can get this to go away. Okay. That's good enough. So this cube has this dimensions, and this rectangle has this dimensions. What would happen if I were to put this in here and tried to fill the tank up with water? Would the tank be able to hold as much water as it had when it was empty? Of course not. In fact, the amount of water they can hold now is exactly this much less. So if we find the volume of this and the volume of this, we can subtract the smaller one from the bigger one and figure out how much space we have left for water. So to find the volume, it's actually not too bad. It's very straightforward. We're just going to multiply length times width times height. So 5 times 4 times 3. 5 times 4 is 20, and times 3 is 60. So now we know that we have 60 centimeters cubed in the big tank. These are all in centimeters, by the way. Okay. And so I'll label this tank over here. For the cube, we have 3, 3, and 3. So what we're going to do is we're going to do the same thing. 3 times 3 times 3. I'm just taking the length times the width times the height. It just so happens it's all the same for a cube. And so 3 cubed is 27. And so all we have to do now is subtract these two to figure out how much space we have left. So the tank minus the cube is going to give us, and I'll line these up so I can do my math right. (33 centimeters cubed. These are all in centimeters cubed. So that's how much space we have left for water. That's your answer. 31 asks, the perpendicular bisector of a line xy is the locus of a point, and then it wants you to finish the sentence. And so basically what they want to know is, do you understand what it means to have a perpendicular bisector of a line xy? And what is the locus? So I'll draw a picture for you to help me explain what that means. So here we have a line, xy, and its perpendicular bisector would look like this. If I can get it to draw straight, it would look like that. So if you'll notice, it's right in between the points. So it doesn't necessarily always look exactly like this. But if you're talking about a locus, what you're trying to say is that there's some form of equidistance between here and here. So this line, this entire line, this perpendicular bisector here, if I put a point on it up here, and I ask you, how far is it from x? You'll tell me it's this far. And I say, how far is it from y? You'll tell me it's this far. And actually, those two distances are exactly the same. And so the answer for this is D, which is equidistance from the point x and y. And hopefully I helped illustrate to you why. So 32 says the midpoint of the point P, x, y, and Q, 8, 6, is 5, 8. Find x and y. So imagining this on a coordinate plane. Let's just say that we had the point 8, 6. And so I'm not going to be so specific about my numbers. I just want to illustrate to you what it would look like. So out here we'll say is the point Q, 8, 6. And they tell us that the midpoint is 5, 8. So I'll go out a little ways, go up a little bit more. We'll call this the midpoint. And then we have a point P up here, and we don't know what it is. We just know it's x and y. So we can actually use the fact that this is a midpoint to solve for x and for y. So by definition, this is literally, you could call it like the average of x and 8. So if I add 8 and this point and I divide it by 2, I'll get 5 because it's the midpoint. And the same goes for the y values. If I take y plus 6 and divide by 2, then I'll get 8. So all I have to do now is solve for x and solve for y. So first I'm going to multiply by 2 on both sides over here. So now I'll have 8 plus x is equal to 10. Then I can subtract 8 from both sides, and now I know that x is equal to 2. So now I'll do the same thing for y. So I again do the same thing, multiply by 2 on both sides. Now I know y plus 6 is equal to 16. And when I subtract 6, I know that y is equal to 10. So my point is 2, 10, which is your answer right here. So question 33 wants us to find the equation of a line perpendicular to 2y is equal to 5x plus 4, which passes through the point 4, 2. So I'll start by writing out the equation of these units. And now what we want to do is find the gradient of this line. So I'm going to divide by 2, and y is equal to 5x plus 2. So the gradient, now that we have this in y equals mx plus b form, is 5/2. But that's of this line. To get the perpendicular gradient, we want to take the negative reciprocal. So that means I'm going to put a negative sign and take the reciprocal. So now it's going to be negative 2/5. This is the gradient that we want for our new line. Also, we need to make it pass through the point 4, 2. And so to do that, we can use this equation. It goes y minus y1 is equal to m times the quantity x minus x1. And you replace y1, m, and x1. So y1 is going to be the y in the point 4, 2. So remember they gave it to us in x, y form. So y1 will now be 2. Our slope, or our gradient, is what we figured out over here, negative 2/5. So negative 2/5, and this is going to change also to the x that they gave us, which is 4. And so now I can solve for 0 to get it in the form that they have, and I can pick the right answer. So I'm going to multiply by 5 on both sides so that I can get rid of this fraction. So now I'll have 5 times y minus 2 is equal to negative 2 times x minus 4. So I can distribute, and I'll have 5y minus 10 is equal to negative 2x plus 8. Continuing to solve for 0, I'll have 5y minus 10 plus 2x, so I move this to the other side, minus 8, I also move that to the other side, is equal to 0. I simplify a little bit, and I will have 5y plus 2x, and negative 10 and negative 8 will make negative 18. So 5y plus 2x minus 18 is equal to 0. So that looks like this one. So question 34 asks us about a right angle triangle, and it tells us that if tangent theta is 3/4, what is cosine theta minus sine theta? So it's hard to draw a right triangle with that. Let's see. Okay. Let's say we have a right triangle. And so, there we go. Okay, so we have a right triangle, and it tells us that tangent is 3/4, tangent theta. So we're going to call this angle right here theta. And tangent, remember from SOHCAHTOA, which is just a way of remembering sine, cosine, and tangent and what they mean. So tangent means opposite over the adjacent. So the opposite side length to this angle is this over here. And the adjacent is going to be right here. Because it's right next to the angle of interest. And so they tell us that tangent is 3/4. So if we have 3/4 and it's opposite over adjacent, that means that 3 is the length of this side, and 4 is the length of the adjacent side. And so they want us to figure out what cosine theta minus sine theta is. Okay, so what is cosine? Cosine is taking the adjacent over the hypotenuse. So this is the adjacent length to the angle, and here's the hypotenuse, but we don't know what the hypotenuse is. So to figure that out, we could just take 3 squared plus 4 squared, because these two sides squared will be equal to this side squared as well. And I'll call this side C. And so we could add these up and find out that they add to 25. And if we take the square root of both sides, we'll get that C is equal to 5. Now, you could do it this way. You could also memorize these three numbers that go together, 3, 4, and 5, where 5 is the hypotenuse and 3, 4 are the side lengths. This is a common set of three numbers that will show up together, and there's other ones similar to 3, 4, and 5 that will show up together for side lengths of right triangles. And I find it very helpful to memorize these, because then you can just look at it and say, oh, there's 3, there's 4, I know that the last side length is going to be 5. Okay, so now we know that this side length is 5. Now we can go ahead and answer the question. So they said cosine theta minus sine theta. So first let's figure out what cosine of theta is. So we said it was going to be adjacent over the hypotenuse. So adjacent length is 4. Hypotenuse length is 5. Now we can do the same thing for sine theta. So for sine, it's going to be opposite over hypotenuse. So the opposite side length is 3. The hypotenuse is 5. And now we just subtract the 2 to figure out what our answer is. So they want cosine minus sine. So I'm going to take 4/5 minus 3/5. Yeah, it's just 1/5. So that's our answer. Question 35 says a man walks 100 meters due west from point X to Y, and then walks 100 meters due north to a point Z. Find the bearing from X to Z. The bearing of X from Z. So what ends up happening is it'll look something. 1, 2, 3, 4. Okay, it'll look something like this. So essentially, here we have point X where he starts. He goes west 100 meters to point Y. Then he goes north 100 meters to point Z. Okay, so this forms the right triangle. And we want to know what is this angle? So we can figure this out by using, well, first we can draw a line like this and make this a perpendicular bisector so that this part right here is 90 degrees. So all we have to do is figure out what this angle is. And so to do that, we can figure out what this angle is using one of the trig functions to figure it out. So they told us that each of these lengths are 100. And so that means, and if you notice that in terms of angles of interest, we have an opposite and a adjacent side to our angle. So that means that we have tangent, because tangent is opposite of our adjacent. So the tangent of this angle theta is equal to 100 over 100, which is equal to 1. So to get the tangent, to get this angle theta, we can take theta is equal to the tangent inverse of 1, which you really want to practice with stuff like this. So the tangent inverse of 1 is going to be 45 degrees. So now that we know that this is 45 degrees, and we know that these two angles together, these two smaller angles, have to add up to 90 to complete this straight line of 180, then we can say that this angle is also 45 degrees. So now we can figure out this full outer angle here by saying 90 plus 45, which is going to be 135 degrees, and our answer is B. So question 36 wants us to find the derivative of the quantity 2x plus 1 and the quantity 3x plus 1 multiplied. So here we have 2x plus 1 and 3x plus 1. So the easiest way to take the derivative of this would be to first multiply these two out, so that we're not trying to use the chain rule or the power rule or some rule to get us to our answer, the product rule, so what I was looking for, because that'd just be too much work. So let's go ahead and multiply 2x plus 1 and 3x plus 1 so we can get something that's easier to work with. So working on the side over here, 2x plus 1, 3x plus 1. We're going to simply FOIL these two out. So first, so that's 2x times 3x is going to be 6x squared. Then we do the two inner terms, the outer terms. So then 2x times 1 is just 2x. Now the inner terms, plus 3x. And now the last ones, plus 1. So we get 6x squared plus, let's see here, 2x plus 3x is 5x plus 1. So now we can take the derivative easily of this, 6x squared plus 5x plus 1. So dx of 6x squared plus 5x plus 1. Okay, so remember with the power rule, when you have x squared, what you're going to do is you're going to bring this 2 down and multiply it by 6. And then you're going to subtract 1 from the 2. So we're going to have 12x the first power, but you can ignore the 1 because anything to the first power is just going to be itself. And then this x, the derivative of x is 1. So it's just going to be 5 times 1, which is just 5. And the derivative of any constant number, which is 1 in our case, will be 0. So plus 0. So essentially we just have 12x plus 5. And that's your answer. So question 37 wants us to find the derivative of sine theta over cosine theta. And there's two ways I can think of telling you how to do this. One of them is very simple, but there's a pitfall if you don't know one specific piece of information. The other one takes more work, but it's possible that it might be easier for you. So we'll see. So I'll show you the easiest way first. So the sine of theta over the cosine of theta is equal to the tangent of theta, because sine over cosine is literally the definition of tangent. So now you're just taking the derivative of tangent theta, which you may or may not know is secant squared. Sorry, put the 2 over here. There you go. However, you may not have memorized that tangent theta is secant squared. If that's the case, then you might be forced to use the quotient rule. So then you would just take, you'd have sine theta over cosine theta. And so the quotient rule says if you take the derivative, this is g, and this is g. If you take the derivative of quotient like this, the top function will be called f, and the bottom function will be called g. So the sine of theta would be f, cosine theta would be g. And the way that you would solve it is you would take first f prime of x times regular g of x minus g prime of x times regular f of x all over regular g of x squared. And so let's go ahead and try that out. So the derivative of sine is cosine. That's what I mean by f prime. So the derivative of sine is cosine, and we're going to multiply it by the bottom function, which is cosine. And then we're going to subtract this next part. So the derivative of cosine this time is negative sine. And we're going to multiply it by the top function, sine theta. All of this is going to be over the bottom function, cosine squared. So cosine times cosine is cosine squared. So I'll write below it. So here we have cosine of theta squared minus, so sine of theta times sine of theta will be sine squared theta, but you'll notice that we have a negative. So the two negatives will become positive, so now we have sine squared theta over cosine squared theta. Remember that cosine squared plus sine squared is equal to 1. And that's an important trig identity. So cosine squared plus sine squared is 1, which means that we have 1 over cosine squared, which is the same thing as saying cosecant squared. Sorry, secant squared. I thought I said that. Secant squared. So you could arrive at the answer in more than one way, but essentially you want to come up with this one. But I highly recommend learning what the derivative of tangent is so that you could arrive at the answer much faster. So question 38 wants us to find the value of x at the minimum point of the curve y equals x cubed plus x squared minus x plus 1. So to help illustrate my point, I went on to Wolfram Alpha and I got this graph that of the equation that they gave us. And so we can see that there's going to be a minimum right around here somewhere, but we don't know exactly what it is. We have to solve for it. But at least we know that the minimum, the x value at the minimum is at least going to be positive. And it's probably going to be some fraction because it's less than 1. So let's get started. So we have the equation x cubed plus x squared minus x plus 1. To start being able to find the minimum point, we need to take the derivative of this and then set that derivative equal to 0. So let's take the derivative of this, and we're going to get 3x squared plus 2x minus 1. And we technically have a plus 0 over here, but we can't ignore that right now. Okay, and now we can set this equal to 0. And so this will give us our critical points. And critical points are just when the derivative is equal to 0. And they could be a minimum or a maximum or like an inflection point or something. But we won't know exactly. We'll have to figure that out after we found the zeros of this derivative. So in order to do this, it's best if we try to split this apart and come up with two quantities. So one of them will be 3x and one of them will be x. And the way, or one of the values of each of these. And the way that I know that is because this first term is 3x squared. That means I need something here and here that will multiply to 3x squared. And the easiest way I can think of doing that is having one of these be 3x and one of these be just x. Now we need to figure out something that will complete these two quantities and leave us with something that can add up to 2x and can be multiplied to get negative 1. And we have to take into account the fact that this is a 3x, not just a regular x. So there's really only so many choices we have because this is negative 1. Since the numbers that we use here, we don't know what exactly it's going to, if it's going to be plus or minus, but the numbers that we put down here have to be negative 1 and positive 1 because we need them to multiply to negative 1. So I'm going to start with putting the negative 1 here and saying plus 1 here. And then let's multiply this out and see what happens. So we can multiply these first two terms. So we'll get 3x squared, then the outer terms, plus 3x, the inner terms, minus x, and then minus 1. So when we simplify this, we get 3x squared, plus 2x minus 1, which is what we started with. So we did it right. So I can get rid of these two now. So now we can set each of these two quantities equal to 0 and figure out what x is. So here, x is very easily, you can tell it's going to be negative 1. Over here, we can do some scratch work on the side. So 3x minus 1 equal to 0. 3x is equal to 1, and then x is equal to 1/3. So now we have these two possibilities. And so, of course, when you're doing the test, you won't have the opportunity to go onto Wolfram Alpha, get a graph of the plot, and figure out, oh, it's probably going to be positive, and then, ignore this value. So what do? How do you know which one of these is the correct value to figure out what the minimum point is? If there's even one, if these are, what if it's not even a minimum point, either one of these? Well, what you can do, and you can do two things. You can plug it in to the original equation, which would be this, x cubed plus x squared minus x plus 1, and figure out which one gives you a smaller value, and that will be your minimum. Or you could also take the second derivative and then check to see what happens when you plug in either one of these two into the second derivative. So I'll explain myself. So this was the first derivative. So if I take its derivative, I'll get the second derivative. So d over dx of 3x squared plus 2x minus 1. So this is going to be 6x plus 2. And so what we can do here is we can solve for 0 of the second derivative and then figure out from there where is the second derivative positive and where is the second derivative negative. And that will tell us whether the original curve is concave up or concave down. So I'm going to write that to the side here. So second derivative tells us concavity. Okay, and if it's positive, that's concave up. And if it's negative, that's concave down. So concave up looks like this, concave down looks like this. So, we can solve for, well, we can do this one of either two ways. We can either solve for 0 and figure out where it is and isn't positive and negative, or we could just plug in what we already got and see if it's positive or negative and see if it's concave down or concave up. So let's go ahead and try that. So at 1/3, then we'll have 6 times 1/3 plus 2, which is going to be, you technically don't even need to solve it. As long as you know that it's positive, then you know that it's going to be concave up. Because there's no reason for this to be negative, right? You're adding two positive numbers, so it's positive value, it's going to be concave up at this point, 1/3. So let's try at -1. Then we're going to have 6 times -1 plus 2. Well, then we're going to have -6 plus 2, which is -4, which is a negative number, which means that it's going to be concave down. Now, imagine that you have a graph, and at one point it's concave up, and at another point it's concave down. Which one are you going to assume is most likely the minimum? The one that's concave down. Now, that's not always the way it goes. It could be that, it's like this. Then something down here would be the minimum or something like that. But that can be checked for by doing a small, sort of like a small plot or a small graph of what the original curve looks like. So you could do it like this. Here's the original equation. Let's try what happens at -1 for this original equation. Well, we're going to have -1 plus +1, which is 0, minus -1 is +1, plus 1 is 2. So we're going to have, at the point -1, we're going to have a value of 2. And then you keep going. You can do another point that's farther down. So we can try 0. So then we'll have 0, 0, 0, and then plus 1. We'll have 1. And then you go on, you try 1/3. And although this is going to be kind of hard, you can just try out these points and figure out by looking at it that 1/3 is definitely going to be your minimum. And so you can work with those numbers and figure it all out. But once you have it down, it's quite a process to learn. But once you have it down, your answer is going to be 1/3.
Question 30 asks us to evaluate the integral of 3 minus 2x dx, and it wants us to do this going from 0 to 1. So I'll write it in the notation as we have it here, 3 minus 2x dx. So the first thing that we want to do is take the integral, or the antiderivative, of 3 minus 2x. So to do that, we just think backwards. What would we have to take the derivative of to get our answer? So for the first one, it's 3x. And then for the next one, it's going to be minus x squared. And so the way I knew that was, well, you can check it. If I told you to take the derivative of this, what would you arrive at? Well, the derivative of 3x is just 3, And the derivative of x squared is 2x. So that's how we know that this is antiderivative. And those always become easier with practice. So I strongly suggest that those antiderivatives are hard for you to practice because they become much easier. So we have this antiderivative, but it's a definite integral, which means that instead of just ending it with plus c, we're going to evaluate it at two different values and subtract. You always start with the bigger value. So we're going from 0 to 1. 1 is the bigger, more positive value. And so we're going to evaluate this function at 1. So 3 times 1 is 3, minus 1 squared, which is just 1. So we'll have this as a quantity, minus, now we evaluate it at 0. Well, 3 times 0 is 0, and 0 squared is 0. So our answer is going to be 2. So here we have question 40, and it wants us to find the integral of cosine of 4x dx. And this time, this integral is not a definite integral, so we're going to have to use a constant with it, which is why you'll see these plus k's. So how do we find the integral of the cosine of 4x? It's a little bit tricky because it's a composition of two functions. We have an outside function, cosine, and the inside function, 4x. So normally, if I asked you what's the cosine of x dx, you could probably easily tell me that it's sine of x. Because when you take the derivative of sine of x, you'll arrive at cosine of x. But this time we have 4x on the inside. So someone might be tempted to say, well, then it would just be sine of 4x. But let's try that. What if I took the derivative of the sine of 4x? What would happen? Well, I would have the cosine of 4x times 4. So I'll rewrite that. I'll have 4 times the cosine of 4x. And that's not quite what we have. We have the cosine of 4x. There's no extra 4. So what happens is, essentially, we started at something that was similar to this sine of 4x, but there was something there that caused this 4 to go away. And that something was the reciprocal of 4. So what I mean by that, and so remember that the reciprocal is the inverse. So instead of 4, its reciprocal is 1/4. So now let's try it again. So if we take the sine of 4x, and this time it's 1/4 times the sine of 4x, and we take its derivative, then this time we'll have 4 times 1/4 times the cosine of 4x. And these two will cancel to 1, and we're left with just the cosine of 4x, which is where we started, that's a good thing, because if we're taking the integral, we want its antiderivative. So it looks like 1/4 times the sine of 4x is going to be our answer. But what if you can't reason yourself through it right away? So there's this method, it's called U substitution, or just substitution in general. And so what you would do is, you would identify the inside function. So like I mentioned earlier, the inside function here is 4x. And the outside function is the cosine function. So to start with, we had an original function. It looked like this. It was f of g of x. And f was the outside function, and g was the inside function. It was a composition of the two functions. And then we took its derivative, and we arrived at the cosine of 4x. And so when you take the derivative of a composition function, you have to use the composition rule, which states that your answer is going to be in the form of f prime evaluated at g of x times g prime of x. So that means that this answer, this cosine of 4x, is in this form right now. So that means that the inside function, like we said, is 4x. So that's g. G of x is 4x. And the outside function is cosine of x. So f of x is, or excuse me, the f prime, because it's in this form, so f prime of g of x. So f prime of x is going to be cosine of x. To take ourselves back to the original form, which was just f and g, we can simply say, okay, so what's the antiderivative of cosine of x? So the antiderivative of cosine of x is going to be sine of x, right? But it was composed with this. So here we go. This is going to lead us to this. So instead of just x, our inside, g of x is 4x. But we're not quite there because, as I mentioned earlier, when we take the derivative of this, we're going to get 4 cosine of 4x. And so you always have to check your answer when you're done and see if there's any simple modifications that you have to do, such as putting a 1/4 in front of it. So there's just two different ways to think about it. So question 41 says that the pie chart shows the distribution of courses offered by students, and it wants to know what percentage of the students offer English. So what it's asking is, here is the section that's composed of the English, and what percentage does it cover of the circle? And so actually the circle is pretty much drawn to scale, and you'll see that there's a straight line going down and a straight line going across, and when that happens, going from the center of the circle outwards, as is shown here, basically these two are perpendicular, and so this is 90 degrees. And so what happens is that we have 90 degrees out of the total 360 degrees that are possible in a circle, which will be 0.25 of the circle, and if we times that by 100, we'll have 25% or 1/4 of the circle. Question 42 shows us a bar chart, and it says that it shows the distribution of SS2 students in a school, and it says finds the total number of students. And so all we have to do is look at where the bars line up according to the numbers, and then add up those numbers. So we're going to have 45 plus 60 plus 30 plus another 45. So I'm going to group these two 45s together and make them 90. So 90 plus 60 plus 30. 60 and 30 makes another 90. So 90 plus 90 equals 180 students total. That's your answer. Question 43 tells us that the sum of 4 consecutive integers, is 34. Find the least of these numbers. So when they say integers, they mean that they're going to be whole numbers, so that makes it easier for us. And they're consecutive, meaning that they happen one right after the other. So if you think about it, let's say I took the numbers 2, 3, 4, and 5. These are consecutive is true, and also saying that each one of these increases by 1 is true. So if I were to start off with, say, I have a number that starts off with, say, x is 1. And 2 would be x plus 1, and 3 would be x plus, let me rewrite that, 3 would be, oh my goodness, I did it again, x plus 2, and x plus 3, and then this would be x plus 4. And so basically I can do that with these numbers as well. So I can have any numbers, x plus 1, x plus 2, x plus 3, and x plus 4. And I'd be adding them because it says the sum, so I'm going to put this here so it doesn't look like I'm multiplying. And the sum of all of these numbers is going to give me 34. So I can simplify and combine like terms. I have 1, 2, 3, 4 x's here. So I have 4x plus 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, is equal to 34. So now I have 4x is equal to 24, because I would subtract 10 from both sides. And now I can divide by 4 on both sides. And I would get x is equal to 6. So I'm not quite done. I have to go back and plug into these original quantities that I have that were standing in for my numbers. So that means I have x plus 1, where x is 6. So the first number is 7, then it would be 8, 9, and 10. And so that would mean that my smallest number is 7, which is what they were asking. Find the least of these numbers. So that's your answer. Question 44 gives us a table, and it wants us to find the median and the range of the data within this table. So the numbers are up here, and the frequency that these numbers appear are down here. So let's start by listing out the numbers in order and by frequency. So the number 0 appeared once. So I'll write a 0 down once. The number 1 appeared 4 times. So 1, 2, 3, 4 times. The number 2 happened 3 times. 2, 2, and 2. 3 was 8. So 1, 2, 3, 4, 5, 6, 7, and 8. 4 happened twice. So 4 and 4. And 5 happened 5 times. 5, 5, 5, 5, and 5. So now it wants us to find the median and the range of the data respectively. So I'm going to find the range first because it's the easiest, and then I'm going to leave it off to the side. Because since it wants it respectively, that means that it wants the median first and then the range. So the range is going to be 5 minus 0. You take the largest number and subtract the smallest number. So 5 minus 0 is just 5. So this is our range up here. So now going on to find the median. To find the median, we basically just go and cross off numbers until we get to the very center. So you could try to find the center by figuring out what it would be mathematically, or you can just cross them out, whichever works best for you. I usually just cross them out, but it might be better for you to solve mathematically by saying what would the halfway point be. So it looks like 3 is going to be our halfway point, and so that means that this is our median. If this data set had been an even number, if there had been, say this 5 hadn't been there, then you would have arrived at a problem where you would have had 2 3s. And so what you would have done is you would have taken the average of those 2, which would still be 3. But anyway, the 5 was there, and this is our median. So they wanted a median and then the range, so median and range, and B is our answer. Question 45 wants us to find the mode of the above distribution. And so what the mode means is the number that appears the most often. So looking at the frequencies, we have 3, 2, 5, and 3. The frequency will decide what the mode will be. So since this is the highest frequency, between 6 and 8 will be the mode. So that means that D is the answer. Question 46 is a question about standard deviation, and it gives us a distribution in the form of a chart, or a table. And so essentially what we need to do is find the average, and then, or the mean, and then use that to help us calculate the standard deviation. So remember that standard deviation is equal to the square root
of the summation of, well, it's going to be the summation of each value minus the mean squared. And then you're going to divide that by however many values there were total. So in our case, we have the numbers 4, 7, and 10 to deal with, and they each occur twice. This occurs 2 times, 2 times, and 2 times. So you'll notice that the total number of data points that we have will be 6. So that'll come in handy later. And so when we multiply these by their frequencies, that'll give us the sum of all of the data points. So this would be 8, 14, and 20. When we add all of these up, we will get, let's see here, we'll have 8 and, I'll do it step by step. So this would be 42. And then we can take 42 divided by the total number, or the total number of data points, and this is our average or our mean, 7. So this can also be referred to as x bar. And now we take each data point, which the actual data would look like this. It would be 4, 4, 7, 7, 10, and 10, because we had 2 4s, 2 7s, and 2 10s. And so we would go about taking the square root of, say, 4 minus 7 squared plus, and then we do 4 minus 7 squared again, but we can just multiply it by 2 to represent both numbers. And then we do the same thing with 7 times 2, and again with 10. 10 minus 7 squared. So this is going to simplify to 0. This will be 2 times negative 3 squared will be 9 plus 0. 10 minus 7 will be 3, squared will be 9, and then it will be times 2. And don't forget that this is all being divided by 6. So going further down, I'll rewrite it to make it clearer. We'll have 18 plus 18 divided by 6. So it will be the square root of 36 divided by 6 is equal to the square root of 6. So this should be your answer. You'll notice that it's not there, so you would leave the question blank.
Question 47 asks, in how many ways can the letters of the word inflation be arranged? And so basically what you want to do is count the number of letters, and however many letters there are, as long as there are no repeats, you can just say it's that number factorial. So since there are no repeats in this word, so for instance there's not 2 A's, there's not 2 O's, there's one of each letter. And we have 1, 2, 3, 4, 5, 6, 7 letters. So our answer is going to be 7 factorial, which is B. Question 48 asks, in how many ways can 5 people sit around a circular table? So I've drawn a picture of a circle, and let's say we had 5 people, X, Y, Z, A, and B, and these letters represent the 5 people. You can choose to fit the first person, let's say A, anywhere. But once you put that first person down, you put a limit on where B can be, X, and Y, and Z. And so, in fact, now B can be in 4 places, and X can be, after that, in 3 places. In terms of around rings, around circular objects, what ends up happening is that you're going to have n minus 1 factorial. So n is the number of people that you start with, or objects, and so we started with 5. So we're going to have 5 minus 1 factorial, so that's 4 factorial. So 4 times 3 times 2 times 1, which is going to be 24. And that's your answer.
Question 49 asks us to find the probability of the number that a number picked at random from the set going from 43 to 60 is a prime number. So remember that for probability, you're going to have what you want out of the total possible, or out of the total set. So the numbers 43 through 60 actually is going to have 4 prime numbers in it, and so I'll go ahead and list the numbers so that I can illustrate to you what I mean. Okay, so if you count out the numbers, there's 18 of them, and only 4 of them, 43, 47, 53, and 59 are prime numbers. So we have 4 out of 18, and so they're saying what's the probability that a number picked at random is a prime number, and that probability would be 4 out of 18. When we simplify that, we can divide both of these by 2, and we'll get 2/9. And so your answer would be C. Question 50 says, in a class of 60 students, 30 offer physics and 40 offer chemistry. What if a student is picked at random from the class, what is the probability that the student offers both physics and chemistry? So in order to do this problem, first we need to find the probability of physics and the probability of chemistry. So for physics, it's going to be the number that you're interested in, which is physics, out of everything. So a total of 60 students will be on the bottom, and 30 will be on the top. And so this is for physics. And for chemistry, they said that there was going to be 40. So this is chemistry. We can simplify both of these. So 30 out of 60 is just 1/2. And 40 out of 60 can be reduced by dividing both of these by 2. So if we divide this, it'll be 20, and this will be 30, and then we can take the zeros away and get 2/3. So we could have also divided by 20. So there's 2/3, and then in order to get the probability of both, we have to multiply the 2. And remember, multiplying fractions, you just go straight across. So it's going to be 2/6, and which reduces to 1/3.